So now to spoofing tools. Yeah, so the easiest way you can start spoofing your local network, or your home network, for example, right now, is to use this ARP spoof utility from Kali Linux, and TCP dump you will already have there. And don't forget to put one into this configuration parameter, right? So putting one to IP forward parameter in sysctl will actually instruct your Linux kernel to pretend as if it's a router box. Okay, so it will route the traffic that it receives on its interfaces according to his understanding of what's going on around him in the network. For example, if he will receive something that is intended to him, he will pass it. He would just accept it and then process. If it receives something that is intended to some other host on the network, it just will pass it through. And if it is getting something that is intended for the outside world to something outside the local network, it will pass it to default gateway. So as you can see, in this situation, the traffic that you are spoofing will be what? Will be just adding up one additional hop to the overall trace to the destination, right? So you will be the first hop, and then you will pass it to default gateway, and so on, as if nothing changed. The TTL will show that you have appeared somewhere, yeah? Okay, so, but remember that you will have to do that. You will have to put this one into this configuration parameter, and you will have to spoof all the targets you want to pass the traffic through you, and their shared gateway, which you should share as well, right? So you have to do that from within the same broadcast segment, from the same local network. Okay, this is the easiest way to do that is, of course, being on the same VLAN with other hosts, or being on the same Wi-Fi. Okay, so you are on the same access point, everything is okay. You can spoof anyone, unless there is a specific configuration that isolates guests or does some other way of protection. You will be able to do that. Yeah, this is kind of really manual. Yeah, so there are ways to automate that. There are these tools, AtterCap and BetterCap. AtterCap is here forever, from a very long time. They have a graphical user interface. That's a tool, that's a framework of tools that allow you to scan what's around you, then select targets, spoof them, and then sniff the traffic to the external file, or just observe it within the session of AtterCap, and so on. It's rather old. It's not really dynamically developed these days, so that's why there is this new tool, BetterCap, which is written in Ruby, I guess, so it's much more portable and much more easy to use. But the paradigm and the usability manner and so on are really very similar to AtterCap. So if you had some experience with that, you will have no trouble switching. So yeah, we will have a demo of BetterCap, of course, later. And now let's proceed to some final crypto and Wi-Fi considerations that you have to be aware of after this. So definitely we will have demos of how to strip SSL traffic, because this is a pretty common situation you can find yourself in, you know. So not because you have to do that within a penetration testing engagement, because yeah, you know, that's normally done by presenting the targets with the SSL certificates they have to explicitly add to their system, and trust from now on, which is kind of hardcore, you know. That's not easily done by the means of social engineering, especially nowadays. Yeah, it's still possible, on a larger scale. If you have a lot of contacts, you can spoof someone in this way, but normally that's not what we rely on right now. And if there is no 0 day in your pocket that you can use in order to do that, I think that's not a very practical approach. So what you can do and what you should do is to use this SSL stripping functionality every time you analyze a application. Okay, so you, for example, have a mobile app that is communicating with a web service somewhere out there, and of course, if you deal with the experienced application developers, they will wrap the traffic into SSL session. Okay, so in order to observe what's going on, in order to dynamically analyze the communication between the mobile application and the web service, you will have to unwrap the SSL. Okay, so for that you will most probably use either burp or OSBZEP proxy. Both of them are quite capable in this regard, but there is also a situation when you will be dealing with some general spoofing and sniffing, and then SSL strip is your tool of choice. Okay, what to do when you encounter strong end-to-end crypto, like in, I don't know, iMessage, Signal, or Viber, or WhatsApp, or secret chats in Telegram. So practically right now, these types of communication are deemed quite protected. So I don't know of any publicly available means of circumventing that protection. So yeah, most probably there are some 0 days in the toolkits of superpowers out there, okay, but I'm not sure this is the level of threat agent we have to emulate in our day-to-day activities. Okay, so yeah, once you encounter strong end-to-end crypto, which is not handwritten, so it's relying on some well respected protocols like Signal framework, for example, Signal API. That's the point where it's okay to stop. Yeah, but if you see that it's handmade, yeah, so someone has constructed his own framework for cryptography, key exchange, message protection, message authentication, and integrity checks, you have to dig deeper, because yeah, the first rule of applied cryptography is what? Is do not implement your own applied cryptography. Okay, so every time you see someone has went through all this way of creating crypto primitives and doing all this more complex stuff, you can be quite sure that there are vulnerabilities that are more or less easily discoverable, and you can exploit that. Okay, so yeah, once it's in line with modern state-of-the-art crypto protection, that's most probably not worth the effort to break it. But still, you can, no problem with that. If you have time and inspiration, no problem. But if you see that that's handmade, that's created from scratch by some programming engineer out there, it's worth attention and trying to break it, because most probably you will succeed. Okay, and what about Wi-Fi? So on Wi-Fi, you can imagine everyone as the member of the same broadcast domain. So it's basically one VLAN shared by all access point guests. Okay, so as many as you have access points, as many VLANs you have. So this is bad. Yeah, so it's bad because it's radio. You don't have to have a physical connection in order to intercept that, and it's bad because it's the worst form of Ethernet possible. Okay, and most access points, most public access points in particular, do not bother with the protection configuration. Okay, even if the equipment allows that, they don't bother. So what you have to do in order to operate with this within this environment. So first of all, you will have to buy some specific hardware that is capable of doing packet injections. So it's like putting your interface in promiscuous mode, but on Wi-Fi. Okay, and you will have to interfere with what other Wi-Fi stations around you do. So you will have to have this new or old or whatever hardware tool that is capable, that's based on the chipset that is capable of injecting packets that are not otherwise expected on the network. Why it's done? Mostly because you will have to imitate a lot of things happening that are not normally happen that often, just in order to make your work more effective, not to wait a lot of time in order to capture all these packets that are required to get a hold of some particular vulnerability in the Wi-Fi protocol. Okay, so we'll have to speed it up, and in order to do that you will have to inject some packets, and for that look towards Alpha Networks, for example. That is the manufacturer of very popular tools of this kind, yeah, and just play around and see what happens. And it's always cool to have an Alpha Network card, external USB card, in your backpack. You never know when you need it. Okay. And what about software? The software you can use is quite different. Yeah, so there is a lot of different options, but the most popular ones are, I guess, this are Kraken G, which is a framework, again, a framework of tools that can be used in order to monitor, to spoof, to inject, to crack traffic. Yeah, so it's quite complicated for a beginner, but there are good tutorials that will get you up to date very quickly. There is Mana, which is especially for a rogue access point creation. Okay, so it's okay to call that now, I guess, as we all are within ethical boundaries. Yeah, so it's rogue. It's pretending to be something legitimate, and if not allowing you to get people fully connect to your access point, but at least you will get some negotiation traffic that normally base access points receive from mobile stations, or on Wi-Fi they don't call that mobile stations. So from other computers and mobile devices, let's say, yeah, via Wi-Fi. And of course in Kali there is a lot of different tools, and there are write-ups on how to do Wi-Fi hacking, cracking, and access point spoofing using the off-the-shelf Kali toolkits. Okay, so I guess for now that's it. The theory is done. We will get to some demonstrations right now. But if you want to know more about this topic, you please proceed first of all to the home pages of these great tools. Yeah, so Wireshark, Scappy, and Bettercup are strongly recommended for everyone to master and use on penetration testing engagements. And there is not much separate reading for that topic. Yeah, so there are pages, there are some blog posts, but most of this theory is laid within large books on the topic, yeah, on network and information security. So you can, of course, Google and read more. But if you really want to get your hands at the problem, there is this actual lab work assignment that you can download and try to perform yourself. So this is like a really practical approach to doing all these things that you have just discussed, yeah, but on a very academic level, and through programming the functions that are required in order to spoof and sniff and do all these really nice things, yeah, what we have just learned. So for theory, that's it. Let's get down to practice.